Day 168 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we made it all the way to day 168, y'all, and we're still going strong. So I hope y'all are still as disciplined as you were on the first day, and I hope y'all are still trying to stay consistent as possible, y'all, because we're really just getting started. They say it takes 10,000 hours if you want to master something, and we're only on day 168. That's nowhere close to 10,000. Not, and it's definitely, give or take, you might spend more than an hour a day, so we could add a few hours in then, but we're not even 1,000 days in, so we're nowhere near 10,000 hours, so that's just something to wrap your mind around as we continue forward, because to let you know that we have a long way to go and we're really just getting started. But don't worry, y'all, it'll all pay off in the end. You know what they say, Swift is the new Python. So as Swift community members, it's up to us to help the Swift community to grow, y'all. They say in the Bible, it says God's judgment comes swift, and then it says the devil is a serpent. You know what I'm saying? So what you gonna do? You gonna do Python, or you gonna rock with Swift? You gonna walk with God and do the Swift, or you gonna walk with the serpent and do Python? I don't know. I'm rocking with Swift. I'm rocking with Swift. That's just me, y'all. But before we get started today, don't forget. Bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could do our part as Swift community members to help the Swift community grow and push this Swift content out to a broader audience, y'all. That's what we're here to do, as well as learning LeetCode. So let's get into the problem. Today we have problem number 705, design HashSet. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all here trying to learn something. And if you don't understand the solution at the end of this video, then you probably didn't learn anything, and that is not what we want, y'all. So let's see what the question says. It says, design a hash map without using any built-in hash table libraries. Implement the HashSet class. Void add key. I don't know what's going on there. Inserts the value key into the hash set. Bool contains key returns whether the value key exists in the hash set or not. Void remove key removes the hash value key in the hash set. If the key does not exist in the hash set, do nothing. So let's look at these examples so we can see what they are talking about, because I can understand how that might be a little confusing. So the first thing, let's look at the input. The input, we have the array of strings, which is just calling the different functions. We have my hash set, that's the class, right? My hash set right here. Then we have add, so that's calling the add function right here. Boom. Then we have some contains. This calls the contains function right here. Boom. And remove. This calls the remove function right here, right? So this is what we're working with. Those are the functions that we're working with. So let's see what they want us to do, because we also have an array of integers, or array of set of integers, right? So let's see. So we have my hash set right here. That corresponds to this right here. All we're really doing is initializing my new hash set, right? So that's why this is an empty array right here. Boom. And that's why this is null. Then we come over to add. We come over to add. Then we come over to 1 right here. So that's saying my hash set add 1. Now the set contains 1, right? This is where we get the 1 from, but we're just adding, so the output is still null. Then we come over and do add again. This time we're adding 2, right? Boom. Add my hash set called add 2. Now the set has 1 and 2, but the output is still null. Now we're coming down here, we're calling contains, and we're calling 1, right? We already added 1 right here. We already added 1 to the set. So my hash set contains 1. We're going to return true because we already added the 1 right here. The 1's right here, so we're going to return true. Then we're going to call contains again. This time we're calling contains 3, right? So my hash set contains 3. The hash set does not contain 3. It only contains a 1 and a 2 so far because we've only added 1 and 2. So we're going to return false because it does not contain a 3. We have not added a 3 yet, which means it does not contain a 3. Then we're going to keep going. Now we're going to add again. We're going to add a 2, right? So my hash set add 2. The set is still with a 1 and a 2 because it's a set, and a set deals with unique elements. So there's not going to be duplicate elements in a set. That's why even though we added a set twice, we're only counting it once because there are no duplicates in a hash set, and that's why the set is still just 1, 2, right? So then after we add 2, now we're calling contains again. We're calling contains 2. Does it contain 2? Yes, it does contain 2. So the output is true because we just added a 2. We added a 2 twice without removing it. So we can return true because we know that there is a 2 in the set, right? Then we're going to call remove, right? And the remove we're going to remove 2. That corresponds to this 2 right here, right? So my hash set dot remove 2. Now the set only has 1. So now that's why this right here is still null because all we did was see if all we did was remove it. We didn't add anything. We didn't see if it contains anything. We just removed it. So if we add or remove, it's going to be a null. But if it's contained, then it'll be true or false. And that's why we're checking now. My hash set contains 2. It returns false, right? This contains right here corresponds to this 2, which corresponds to this false, which corresponds to this right here in the explanation. And it says my hash set contains 2. We're going to return false like we did right here because we just removed the 2 before. So we removed the 2 right here. This remove corresponds to this 2, and that's why, and this null right here, my hash set remove 2. So now we're checking to see if it contains 2, and it does not contain 2 because we just removed it. So that is a little bit. Let's see if there's another explanation. Nope. So that's how the question works. I hope that makes sense to y'all, but you could just understand each index corresponds to each index, and what we're adding and in the output. So and in the explanation. So if you want to go over it again by yourself, just understand that each index in the input corresponds to each index in the output and corresponds to each explanation. So now that we understand the code, let's get into it. Let's get into the question now that we understand the question, let's get into the code, the part that all keeps us going, the part that keeps us motivated. Let's get started. The first thing we are going to do, right, is we are just going to create a private variable. So we're going to say private var data, equals bool. So it's going to equal bool, and it's going to be repeating, or an array of booleans. Data is going to be an array of booleans, and it's going to be then come outside of that bool, open up the parentheses, and say repeating. So this is how we're going to initialize it. We're going to say repeating false. So it's going to be an array of falses, and then we're going to say count up to count. We could just make it a crazy number so that everything works fine. Since this is not a real project or anything, we could just give it a random number that we know we won't go over, right? That's why the number's so high, because we'd rather it be too long than too short. So then we're going to come down here, right? And the first thing we are going to do, we're just going to say data, open up the square brackets, key equals true. So what this is going to do, right, it's going to give us a key. Say key is 1. It's going to go to the corresponding index in this array, this data array that we created. It's going to say key is 1. It'll go to index 1 and change it to true, because right now all of the indexes is just repeating false. All the indexes are false starting off when we initialize it. So this is what it's going to do, is this is going to go to the key, or the index. The key is an integer. In this case, or this example, we'll just say it's 1. It'll go to the index 1 of this Boolean array and change that index 1 to true. And that'll let us know that now 1 is in the set. And we're going to do the same thing for false. We are going to say data, open up the square brackets, key equals, equals false. Or I mean, we're going to do the same thing for remove. So when we remove a key, say right here we're adding the key and the key is 1. So we're going to go to the repeating, we're going to go into the array of index 1, turn that to true. But say we want to remove that key, right? So then we'll go to index 1 and turn it back to false. And then we're going to do the contains and we're just going to say data key. So this is going to check if it's going to return a boolean. So if the data key exists, it'll say true, and if it doesn't exist, it'll check the index and say true. If it doesn't exist, it'll check the index and the index will be false, and that's how we will know if it's in the set or not, right? So let's one more time, let's go through this before we submit it. This right here is going to create an array of Boolean values all the way up to, it's going to be repeating falses in the array all the way up to the count of, what number is this? It'll be 100,000 or 1,000,001, right? What's that, 1 million? Yeah, that's 1 million. So it's going to be 1,000,001 falses in this array, right? What this is going to do is we're going to get a key. The key is going to be an integer. Whatever that integer is, say the example like we were using 1. Say the integer is 1. So the key is 1. It's going to go to this array, this Boolean array that has 1,000,001 falses. It's going to go, or it's going to have, this array has 1,000,001 indexes. They're all false. It's going to go to index 1 and change that false into a true, right? That's what happens when we call this add function. Then if we want to remove it, it's going to go to this array that has 1,000,001 falses, or it might have 1 true. It'll have 1 true and 1,000,000 falses. It's going to change that true back to false, right? If the key is still 1, it's going to go to index 1 and it's going to change that index 1 from true back to false, right? And what this contains function is going to do is going to go to this index or key, which say we're working with key value of 1. So this is going to go to check index 1 and check to see if it says true or false. If it says true, that means that index 1 is, or that means 1 is in the set. If it says false, that means 1 is not in the set, or the set does not contain 1. Right? So if it does contain 1, it's going to return true. If it doesn't contain 1, it's going to return false. So let's run it. Fingers crossed, fingers crossed. Whenever you have one of those pesky bugs, y'all, just make sure you pray, or make sure when you say you fix one of those bugs that take a week or so to fix, y'all, just make sure you tell God thank you for helping you to fix that bug, y'all, because we're definitely going to need God with us on this LeetCode journey, because there's going to be a lot of frustrations and there's going to be a lot of temptations to give up, but we're not going to, y'all. And look at that, y'all. It's accepted. So let's submit it. Make sure it stays accepted. Let's see. And oh, look at that, y'all. That's what I'm talking about. 10 milliseconds beats 100% of users with Swift, y'all. That's faster than a Bugatti riding past all the brokies on the highway, y'all. That's what we like to do. That's what we do, because we're Swift programmers, y'all. So I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.